Hi everybody, we're going to be talking about composite functions. I know you've talked about functions in the past, but what we are talking about is actually putting functions inside of other functions. You might refer to a function or seeing a function in the past as f of x or g of x, okay? But now you're going to start seeing some things that refer to this g of x function actually being put into the f function. We're going to call that f of g of x. And you also might see it as this fog thing here, where it's just a tiny little circle, but this does in fact mean that g is nested inside of f, meaning that the g function is replacing all of the x values in your f function. Okay. We also might see g of f of x, which just means that your f function is nested inside of your g function. And you might also see gof, we sometimes refer to it, but that just means that your f function is replacing all of the x values in your g function. So let's just kind of get down to the nitty-gritty and see what some of these examples may or may not look like. Right now I'm going to define f of x as being x squared. And then I'm going to define g of x as being x minus 3. If I want to find f of 3, I'm going to take this 3 right here and I'm going to put it into the x values of my f function. And so I'm essentially going to say that would be 3 squared. Well, you know that 3 squared is 9. And so what we would say then is that f of 3 is in fact 9. You also might remember that the 3 is an x value and the 9 is the resulting y value. So this could also be a point that's graphed on a coordinate plane, where if we went out 3 spaces and then up 9 spaces, that point would be graphed right there. So you can pull function values from a graph if you're given that picture of some sort of graph as well. Okay, now let's talk about this g function that we have here. Remember, I defined g of x as being x minus 3. And so what I'd like us to find right now is g of 9. So we're going to take 9 and we're going to insert it into the x values of g of x. So that would be 9 minus 3, which is in fact 6. And so if I was graphing a point there, I would graph the point 9, 6. Okay, so right about there would be that point. All right, so that is something that should all be a review. And so now let's talk about what we mean when we talk about composite functions. If I asked you to find f of g of x, right here, I'm asking you to take this x minus 3 and put it into the x values of the f of x function. And so I want to say, all right, well, f of x is something squared, and I'm going to fill that something with my x minus 3. At this point, we could FOIL those two quantities together, and so we would have x squared minus 6x plus 9 as our final answer. That function would be referred to as f of g of x. I could also ask you to find g of f of x, right? So with g of f of x, I'm going to erase some of this here. We're going to go the other way, and we're now going to take the f function and put it into the g function. So I'm going to take this x squared now and insert it into every x that I see in g of x. And so in this case, we would have x squared minus 3. There's nothing else I can do with that. So g of f of x is equal to x squared minus 3. So let's kind of take things a step farther. Right now I'm giving you f of x, g of x, and h of x. And what I would like us to look for is to find f of g of h of x. It's a mouthful, isn't it? But what we're doing is we're going to start from the inside out. We're going to take the h of x function and insert him into the x's of the g of x function. And then we're going to take that answer and insert them into the x's of the f of x function. All right, are you ready? So here we go. Let's take x plus 3. We're going to take x plus 3 and put it into x to the 10th. So that f of g of h of x. Okay. And so let's work on that h of x first. So I'm going to put x plus 3 in x to the 10th. Okay. If you'll notice, that is actually just g of h of x. And now what we're going to do is take g of h of x and put it into all of the x's of f of x. Well, I have an x in the top and an x in the bottom. So this quantity right here, the x plus 3 raised to the 10th power, must go in both places. So we would have x plus 3 to the 10th all divided by x plus 3 to the 10th. And then we have plus 1 tagged onto the outside. Okay? So that would be putting 3 of them inside of each other. Okay, and then this last question, I would like you to find f of x and g of x if I already have composed them for you, and you are now going to be breaking them apart. There's a couple different ways you can look at this, and there's actually not just one answer. You could have multiple, but you really do want to look for one function nested inside of another function. If I look at this right now, I see that I have this x plus 9 kind of inside of that fourth root power. So the inside function is the g of x function. So I'm right now just going to define g of x as x plus 9. If g of x is then x plus 9, what would f of x have to be? Well, it's nested inside of this fourth root. Let me erase that and we'll see it a little bit clearer. But you want to make sure that what goes inside is what is being the placeholder for the g of x function. So actually I only want an x underneath that fourth root. If you want to check yourself, you should be able to just put your x plus 9 back in to replace the x. If you did, would you have this original answer? Sure you would. Okay? Now, that's not the only answer that you could have. Okay? So, we could realize that a fourth root is actually made up of a square root inside of a square root. So if you wanted to think of f of g of x in that way, you could say, oh, well, that would be the square root of the square root of x plus 9. And so in this way, now you could look at the square root of x plus 9 as your nested function inside, and then the square root function also being your outer function. So in this case, we would say g of x is the square root, and I don't need that 2 there, but I just put it there just to have fun. So g of x would be my square root of x plus 9, and then f of x would result in just the square root of x. And so you can check to see that if I put my square root of x plus 9 back into that x, I would have the fourth root of x plus 9. I hope this made sense. I know this is a quick run through, and we will get lots more practice as we work together in class. Have a good day, everybody. We'll talk to you later.